Hey guys, in this video we're going to be checking out the Nano X from FlexRC. This is a 57mm 1S brushless micro, and it's kind of unique with some pretty unique motors on here. These are FlexRC branded 1102 16,500 kV motors. So these are rebranded DYS motors. I don't think that DYS sells them separately. I think you can only get these at the FlexRC website. Now, other than the motors, this has all the same components as the Dust X58 that I reviewed maybe it was a month and a half ago. It's got the same CM275T all-in-one camera, the same Tiny Fish flight controller, and 4-in-1 ESC. It's a 4-amp 4-in-1 ESC, but it's only 1S rated. The props are different. These are the Eachine 1535 4-bladed props. And these are actually pretty good. I didn't actually use these screws to save weight because I just press fitted the center hole onto the motor shaft, and it went down fine, and these don't fly off. I just went as far as I could on some of these motors. They wouldn't go down any further no matter how hard I pushed, so I just left it alone. I don't think that those are going to be coming off. It's just these two here. The other two went all the way flush. So the overall weight of this is 28.5 grams. I elected to not use the prop guards. So the prop guard clips on with this little carbon fiber adapter, and you're supposed to clip this in before you screw on the motors. So just be aware of that. I did not want to use the prop guards, which is why I didn't actually put it on. But you would actually put it in here, and it would clip onto the edge there, and then the prop guard would clip into the four standoffs here, and so the prop guard would then go into the adapter like this. And they definitely want to put this on before you put on the motors, and I think that is a little bit fiddly, so you probably want to set up this frame before you put all of the electronics in. And I'll just keep in mind that having this on the frame while you're building it will make it also a little bit more difficult. And this build is probably one of the more challenging builds, so just be aware of that. So by not using the prop guard pieces, I saved about 4 grams of weight, so just something to keep in mind. So this is billed as a 1S brushless indoor flyer, and I think that using the 16,500 kV 1102 size motors is an advantage over the ones that came in the Dust X58. Those are 0703. I think those motors are more fragile and more prone to damage from crashes. Specifically, the motor shaft is very, very thin. I think it's a 1mm motor shaft, and that tends to bend or break in a lot of crashes. This is a 1.5mm motor shaft. This is a much heftier motor, and I crashed it quite a bit actually. I'll explain that why in a little bit, but it had to do with my initial testing, and I didn't even break any props on this. So you could fly this indoors and not use the prop guard, although I think that the props would probably damage things in your house versus the props actually breaking. This is actually the original set, and I've crashed this a ton, and these props haven't even bent. I think it's just because this it has no mass. It only weighs 20.5 grams as it is, so you just aren't going to damage much stuff, and this isn't going to get damaged hardly at all in any kind of type of crashes. So let me talk about a little bit how I put this together. It is quite a tricky build, so let me just explain how this works. So what happens is you get this little Tiny Fish flight controller plus the 4-in EC. They're already all the pieces are soldered together, and it's actually screwed together. You got to take that apart, and then you end up with a bunch of like little spacers and this long white screw. And here's one that there was spare here. This white screw goes all the way through, and the little end here sticks into the little camera mount here, and I'll explain how that gets on in a second. So what I did, and I'm going to show you some high resolution photos because it's kind of hard to see in the video. I first put on this little battery plate into the screw, use a spacer, and then I put the 4-in-1 EC on. And I did not desolder anything. You can if you want to, but it wasn't necessary. And then I used a nut here to screw down the ESC to secure this part, and then the remaining screw would be sticking out at that point. And at that point I put on the main plate, and at first I actually put it on incorrectly. I had it rotated 45 degrees. You have to actually use the smaller holes here for the main plate, otherwise it's going to be crooked. And it turned out that the screw here was, or the screw hole was too small for the screw, so I had to drill it out a little bit to get that screw through. And basically you want to stick the main plate in between the ESC and the flight controller, and I was able to slide the main plate through, and then had enough of these little wires here, the ESC signal wires, just enough slack there to pop on the flight controller on top of the 4 screws. And I only used the spacers in the front, not in the back. That's just a screw you're seeing right there. And then to secure the flight controller down, I actually didn't have enough space to put another nut in there. So these holes in the camera mount are really tight, and so I just press fitted them down in all 4 of these, and they seem to be holding up just fine. It was actually really difficult to get them on there, and you can't actually screw the screw into there because it won't rotate. And it's just I was actually stripping the nut here, or the screw head, to try and screw that in there. So it's just easier to press them down with your finger, and then once you do all 4, it'll stay pretty secure. It hadn't come off in any of the crashes that I've experienced. And I then was able to mount the camera here. I used a little bit of hot glue in the front there to keep it in, otherwise it'll just pop right off. It's not a very tight fit. But you can see I got quite a bit of camera tilt here. I wasn't able to, because of the way the camera mount is set up, wasn't able to get the camera all the way down in to the point where it meets the this lens adapter here. So there's a little bit of a gap, so there's a lot of camera tilt. So I ended up realizing I couldn't fly this indoors. So yeah, I think that if you want to fly it indoors, you're going to probably want to reduce your camera tilt so it's facing more forward, so that you can fly inside. Otherwise when you tilt it over this much, it goes really fast. And you'll see in the video when I flew it outside, and actually in pretty windy conditions, probably a good 10 to 15 mile an hour wind, and it was having no trouble flying in that with the camera tilt that I had. And the camera here is soldered directly to where the power comes in. So there's a battery lead that goes to the ESC, and then there's a little power lead that goes from there to the flight controller. It's taking direct 1S battery voltage. And then I just soldered on my power wires for the camera to the 1S power. So it just gets 1S power directly from the battery in that method. Okay, so once I got all that mounted, I then at that point proceeded to put on the 4 motors. And I know that some people will say that they should put the motors on first and then solder them to the ESCs first, but I actually found this to be easier. Once I had the whole stack and everything all secured, the camera in, everything, all the wires out of the way, it was pretty easy to just put the motors on. So I just screwed on the motors, which I just used 2 screws here. And of course the wires are extremely long, so I cut them short. And it's just not, I'm not sure if this is going to come out. It's kind of hard to focus there. But I have the wire going from the motor around, because if you go directly to the nearest ESC pads, it's way too short. So I crisscrossed these, and then I soldered them underneath here. See if I can get that to show up. So you can see that the wires go from the motor this way, and then I have the 3 there. It was tricky, but actually not as hard as I thought it was going to be. And I actually did 1 wire at a time. I cut them to the length that I needed, and then soldered them directly in here. I did have to do some motor resource remapping, because obviously I didn't have everything in the right motors to the right ESCs. I think I had it rotated, and so I did that. And then I also had to change motor directions in BL Heli configurator. So that's the stuff that's pretty simple for these micros. I've done that before, but you should be aware that you probably want to do that for this, because you're going to be rotating the board, or the ESCs in this case, and you're going to need to do that to get the motors in the right spots, otherwise it won't fly. To secure the battery, all I'm using is a rubber band, and that seems to be working just fine. It actually hasn't even come off in crashes. I think that to properly secure the rubber band, I will probably use a zip tie here in this hole to secure the rubber band to this little side standoff here, and then that should prevent it from flying off, but it hasn't flown off yet in any of my crashes. One other thing that you want to be aware of is that the heat shrink here that comes out of the motor to the motor wires will rub against the motor once you screw down the motor to the main plate. And so what I did was I just used some pliers and squeezed down the motor wires until they weren't rubbing anymore. And so if they're rubbing, their motors will probably not spin freely. So you want to do that for all four of them and make sure that they're spinning freely. But once you get that gap there, it should be just fine. Okay, so now I want to talk about the problems I was having getting this to fly after I had finished building it. And it had everything to do with the battery. So very, very important. I think that the battery technology is just not keeping up with the motors. And these 1102 16,500 kV motors, they're drawing quite a bit of power on a 1S battery. And these 1S batteries that I had weren't that good. If you compare that to the Dust X58 here, it was using a micro low-C connector with these 0703 motors. It wasn't drawing as much power, and I was able to use those batteries just fine. But those batteries wouldn't work on the Nano X, and I'll only explain why. So the battery that I was trying to use is this Nanotech 500 milliamp hour. It's a 2550C battery. It's pretty good battery. It's decent, not like awesome or anything like that. Honestly, I haven't found a totally awesome 1S battery to be totally truthful. So I was using this little adapter here because I needed to use a JST here for this one instead of the micro low-C. And on the Dust X58, this battery flew just fine. I could get pretty good flight times. I think maybe it was like 3.5 minutes, something like that, 4 minutes. But when I flew it on here with this adapter, it would take off, hover for maybe 10 seconds, and then I would get a telemetry loss, telemetry recovered error. And I would get those occasionally on the Dust X58 towards the end of the battery. I think it's because the receiver on this built-in receiver on the Tiny Fish is susceptible to brownouts. I think that as the voltage sags and it loses current, the receiver browns out, and then you get the telemetry lost, telemetry recovered error on your Tyrannus. And what that actually is actually a failsafe. And so it would fail safe for a fraction of a second and come back. And towards the end of the battery on this guy, I would know that it would be time to land because I knew that was a failsafe. But I could fly for 2-3 minutes no problem before I started getting those error messages. I was getting that within 10 seconds on the Nano X with the same battery, and I couldn't figure out why it was doing that. And I tried this battery, I tried a few other batteries, and then I realized that using this little adapter here, going from micro low-C to JST, was the actual problem. I think that what's going on here is that there's loss of efficiency when you use a connecting adapter here, and may not be that big of a problem on something that draws less power like this one, but it is a problem on this guy that draws quite a bit more power. So I realized I couldn't use this battery, at least in this current form. I would have to probably switch this connector out. I did find a different battery, and that was in my battery bay that I hadn't used in a long time. It's a 600 milliamp hour 30C battery. I don't even remember what this came with. It came with some toy quad, maybe some JJRC brand. I don't remember. But this battery worked, so I charged it up and was able to fly it around no problem because it wasn't using an adapter. I could just plug it directly in. It is a little bit heavier than I think that I saw Dimitri flying. I think it was one of those tiny whip batteries. It was with a power whip connector. So I actually tried that too. So you'll see in the flight demo that I was actually using this My Lipo battery, 255 milliamp hour, 25 to 50C. It says the PH connector or the 2.0 connector, and yeah, he was using an adapter here. And apparently this adapter wasn't causing that big of a problem, I was able to fly it in this setup. I think this battery is a pretty good battery. It just probably has a very low internal resistance, pretty high C rating, so that's probably why it was working better. And it's a lot lighter, so it's not drawing as much power. However, because it's only 255 milliamps and it's drawing a lot of power, I got very, very short flight times with this setup here. I couldn't tell you exactly. It was probably under 2 minutes, maybe a minute and a half, 2 minutes, so it wasn't really all that worth it. It was fine for doing the line of sight testing, but I don't think I'll be flying in the future with this. Just the flights are too short to be very useful, although maybe if I want to do some like a quick acro flight, I could probably do that. With the heavier 600 milliamp hour battery, I probably can't do too much acro. I was able to do some flips and stuff with the line of sight with my LiPo battery because it's a lot lighter, but I had trouble with this battery. It was harder to recover, and I think I tried one roll and I crashed because it just dropped so fast. So I recommend that you get batteries that have the JST connector already on them. Dimitri was very helpful, and he provided me a couple of batteries he thought would be pretty good, and I'll put links to those in the description. I think there's ones from Hobby King, and I forget where the other one's from, but they come with the JST connector already. Alternatively, you could take your battery with the micro low-C connector, cut off this micro low-C, and then put on a JST instead. And I actually tried that with this battery here. This is 600 milliamp hour battery, and I just cut off the micro low-C connector and soldered on a JST, and I was able to fly with this one as well. Honestly, I couldn't tell the difference between these two batteries. They're about the same size and weight, you can see here. So I think that you could take these sort of mediocre 1S LiPos. I think this came with the Eugene QX90, and solder on a JST, get rid of the micro low-C connector, and then it'll work with the JST here. I think you got to stick with the JST. I think if you're thinking about swapping out the JST for micro low-C, you're going to probably run into some issues because these motors draw more power, I think. A couple other things before I show you the flight demo. When you plug in the USB to your computer, you need to have battery power, otherwise it won't do anything. The board needs battery power in order to communicate with the computer. I'm not going to go over a Betaflight setup. I will just put a CLI dump link in the description. You can go over my settings and my PIDs. There's no OSD or anything like that, so you basically have to tune it. Basically you have to fly it, figure out what's wrong, land it, plug it into the computer, change your PIDs, fly it again. So it took a little while to find some PIDs that I liked. They're actually a little bit different from the stock PIDs, but you'll see in the flight. I think it flew pretty smooth and pretty fast, at least for like cruising around the park. Anyway, I think this is probably one of the more challenging builds because the soldering is fairly difficult and challenging because you're soldering to very tiny points, especially the little motor wires here. I have a lot of experience soldering small stuff, so it wasn't too bad for me. I actually got this built fairly quickly, probably a couple of hours, so it wasn't too bad. But if you have difficulty soldering to very small solder points and have shaky hands or something like that, this is probably going to be a difficult build for you. I would have to rank this as on a scale of 1 to 10, probably close to a 8 or 9 easy in terms of difficulty, so quite difficult. But if you're an experienced builder, I think this is a really nice frame. I like the design. Everything's nice and compact. And I think compared to the Dust X58, you can see here, the camera doesn't sit up quite as high. I think it's a little bit more balanced. And I think this one actually flies a little bit nicer than this one. They're both pretty noisy. These motors are very rattly and noisy. I know that a lot of people have crashed these and have broken the motor stems, so and I think that these motors are definitely more prone to breakage from crashes, so there's something to be aware of. But this is a little bit lighter. I think this is 21 grams or something like that. Watch that video, I forget the actual weight of this. And then this is going to be a little heavy, but these motors are much better. So I think that for 1S brushless, I think these motors are probably going to be the way to go for the future. Anyway guys, I'm going to go ahead and roll some line of sight flight demo and also the FPV flight. You'll see that flies pretty good. Let me know if you guys have any questions about this, and I'll talk to you guys in the next one. This thing is so tiny, it's kind of hard to see what I'm doing, but I am doing a few flips and rolls here, and it seems to be doing just fine with the small LiPo. I think with the heavier battery it's going to be a little bit more difficult to do those tricks. So I think with all this camera tilt, this is actually flying a lot faster than I was expecting. And even in windy conditions, just with a 1S LiPo, and not a very good 1S LiPo, it seems to fly fairly well. I'm still working on this tune. I will put the CLI dump in the description, but keep in mind that it's not finalized, that I'm still working on it. You can see it's still kind of bouncing around a little bit because of the wind, and it is kind of small, so the tuning of this is not going to be particularly easy, so it's going to take a little more time to get this tuned right. So these two guys over here are checking out the drone. They can't see it, but they can hear it because these props are so loud because of the high kV. And I was bringing it closer to show them what it looked like, but they're like, "Where is it? Where is it? I don't see it."